Assalamualaikum warahmatullahi wabarakatuh and a very good day. I am Nur Syahira binti Syahrin and my partner is Hazwani binti Harun. So we will present to fulfill our second task for subject mathematical processes. So for our task, we will present the topic of integrated mathematical processes to improve the quality of teaching and learning of secondary school mathematics. Next, as we can see, mathematical processes that support effective and meaningful teaching and learning are problem solving, reasoning, mathematical communications, making connections, and representations. These 5 interrelated mathematical processes need to be implemented and integrated across the curriculum. For our group, from 5, we choose 2. We choose mathematical processes as problem solving and mathematical communications. So I will present for a problem solving part, and then we continue with Hazwani, which is the part of mathematical communication. Problem solving is the heart of mathematics. Hence, problem-solving skill must be developed comprehensively and integrated across the mathematics curriculum. Problem-solving and mathematical processes are the backbone of the teaching and learning of mathematics, which is fundamental to teaching and learning math. So they should produce students capable of using various problem-solving strategies, higher order, critical, creative, and innovative thinking skill. The teachers need to design teaching and learning sessions that make a problem solving the focus of the discussions. Activities carried out should engage the student actively and pose diverse questions and tasks that contain routine questions and non-routine problems involving non-routine questions, which need thinking and reasoning at a higher level. So the teacher should cultivate this skill consistently to produce students who can compete in the global market. Let's move on to the next part. So the integrating mathematics as a problem solving in the classroom can significantly enhance student understanding and engagement with the subjects. So here are some strategies to achieve this. So first strategy is presenting students with a real world problem that require mathematical concept to solve. So this could include calculating distance, budgets, or proportion based on scenario relevant to their life. So this helps students see the practical applications of mathematics. Teachers also can pose open-ended questions with multiple possible solutions or approaches. So please encourage students to explore different strategies and justify their reasoning. So this fosters critical thinking and allows for creativity in problem solving amongst the students. Integrating problem solving in class can promote collaborative problem solving activities where students work in groups to tackle challenging problems. This encourages peer learning, communications, and teamwork as students discuss different approaches and share their insights. So next, we use visual aids, manipulative or digital tools to help students visualize mathematical concepts and model real-world situations. This can make abstract concepts more concrete and accessible, facilitating a more profound understanding. Provide a scaffolded problem that gradually increases complexity, allowing students to build upon their existing knowledge and skill. So start with more straightforward issues and progressively introduce more challenging ones as students develop confidence and proficiency. Next strategy is inquiry-based learning. So adopt an inquiry-based approach where students are encouraged to ask questions, explore mathematical concepts independently, and discover solutions through investigation and experimentation. So this cultivates a curiosity and a deeper understanding of mathematical principles. Next, by reflections and meta-connections, it encourages students to reflect on their problem-solving process, including what strategy they use, what worked well, and what they found challenging. So this promotes metacognitive awareness and helps students develop problem-solving skill more effectively. For differentiate instructions, so first, recognize and accommodate diverse learning style and abilities by offering a variety of problem-solving tasks that cater to different needs and interests. So this ensures that all students are appropriately challenged and engaged. Moreover, use formative assessment technique such as quizzes, exit ticket, or classroom discussion to gauge students' understanding of mathematical concept and identify areas where they may need additional support or instructions. Feedback and encouragements also can provide constructive feedback and positive reinforcement to students as they engage in problem-solving activities. So celebrate their success and encourage resilience in the face of challenges. So by integrating this strategy into mathematics classroom, we can create a dynamic learning environment that promotes more profound understanding and proficiency in problem-solving skill. Let's take a look, for example, based on the strategy that we discussed earlier one by one. So let's take a geometry example. So this example to illustrate how you can integrate problem solving in the teaching and learning activities to enhance understanding among students. So the example is calculating the area of irregular shapes. So based on the first strategy, which is real world contact, so we present students with a scenario where they need to calculate the area of garden bed in their backyard, which has an irregular shape due to the presence of trees and bushes. So for the second part, pose the questions such as how can we calculate the area of this irregular garden bed? So this encourages students to brainstorm different strategy and discuss their idea with their peers. For the next part, divide students into the small group and provide them with the measurement and a diagram of the garden bed. So instruct them to devise a plan to calculate the area using the information. So this example based on the collaborative problem solving. So for the fourth strategy, modeling and visualizations, we provide grid paper or digital tools that allow students to sketch the irregular shapes of the garden bed and break it down into the simpler geometric shape such as rectangles, triangles, or trapezoid. We also can start with a simpler versions of the problem, such as calculating the area of rectangle or triangle within the garden bed. Then, gradually introduce more complex elements, such as overlapping shapes or irregular boundaries. Next, for the inquiry-based learning, encourage students to explore the different methods for calculating the area, such as using formula for basic shapes, dividing the shape into the smaller regions, or estimating the area using the counting or approximation techniques. By reflection and metacognitions, so after the student have solved the problem, facilitate a class discussion where they reflect on their problem-solving process. We can ask the questions such as, what strategy did you use to calculate the area? And how did you decide which approach to take? By differentiate instructions, we can offer support and extension activity based on student needs. We can provide additional guidance and resources for students who may struggle with the concept while challenging advanced students with more complex variations of the problems. By formative assessment, we can circulate among student group as they work on the problem, observing their problem-solving strategy and providing feedback as needed. We can use informal evaluation such as questionings or observations to gauge student understanding throughout the lessons. By feedback and encouragement, provide positive feedback to students for their effort and insight during the problem-solving activities. We can emphasize the importance of perseverance and creative thinking in tackling mathematical challenges. So by engaging students in these problem-solving activities, we can reinforce their understanding of geometric concepts and cultivate their critical thinking, collaborations, and communication skill. As you can see, here an example of how we might integrate problem solving into the mathematics class using the concept of proportions. So first, we state the scenario. Based on the scenario, we can state the problem statement. Then, what tasks we have to do. So followed by the step, consists real world contact, data collections, problem solving process, calculation, reflection, and extension. First part, we start with the scenario. So the scenario is planning a school trip. So next, how about a problem statement? So the problem statement is based on the scenario. So we can say that planning a field trip to a nearby city. So we must determine the number of buses required for the trip based on the number of students attending and the capacity of each bus. So let's move on to the task. Based on the previous informations, we have to calculate the number of buses needed for the trip. After we get the problem statement and the task to fulfill, we move on to the next part, which is steps. So our step consists of 6 steps. For the first step is the real world contact. So we start by discussing the importance of proportions in real life situations, such as planning event or managing resources, such as number of buses needed for all students. Second, by collecting data, it provides students with the following information. So we have a number of students attending to the trip is 120 students. This is including boys and girls. While bus capacity is 50 students per bus. Third, begin by discussing the concept of proportions and how they can be used to solve problems like this. First, we can set up the proportion, which is, as you can see, number of students over student per bus equal to number of buses over 1. Next, we substitute the given value into the proportions. As we know, number of students we can substitute with 120, while student per bus we can substitute with 50, equal to number of buses over 1. Next, we solve for the unknown variable, which is number of buses. We continue the next part in calculations. Since we can have a fractions of a bus, so we can round up to the nearest whole number. So therefore, we need 3 buses for the trip. In reflection part, we discuss the solutions as a class, encouraging students to explain their reasoning and the step they took to solve the problem. We can reflect on the significance of rounding up to the nearest whole number in the context of planning practical event. We can ask students to consider variations of the problem, such as different bus capacity or number of students, and how the solution would change. Last but not least, challenge students to think about the other factor that might influence the planning of the trip, such as cost considerations or scheduling constraints. We also can have the student explore the alternative solutions, such as using smaller vehicles if buses are unavailable, or calculating the number of chaperones needed based on the student to chaperone ratio. After all the steps we follow, engage students in this problem-solving activity. We not only reinforcing their understanding of proportions, but also helping them develop critical thinking skill and apply mathematical concept to a real-world situation.
Now I will proceed to mathematical communication. Communication in mathematics is the process of expressing ideas and understanding verbal, visual, or written form using numbers, notation, symbols, diagram, graph, picture, or words. Communication is an important process in learning mathematics because mathematical communications help people to clarify and reinforce their understanding of mathematics. Through communications, mathematics idea can be better expressed and understood. Communication in mathematics, either verbally in written form of using symbol and visual representations, such as chart, graph, diagrams, can help people to understand and apply mathematics effectively. Teachers should be aware of the opportunities that exist in teaching and learning sessions to encourage people to express and present their mathematical ideas by using appropriate questioning technique. Communications that involve a variety of perspectives and points of view help pupils to better improve their mathematical understanding, which enhance their self-confidence. The significant aspect of mathematical communication is the ability to provide effective explanation as well as to understand and apply the correct mathematical notation. People should use the mathematical language and symbol correctly to ensure that mathematical idea can be explained precisely. Effective communication requires an environment that is always sensitive to the needs of people so that they feel comfortable by speaking, asking and answering questions, explaining and justifying their views and statements to their classmates and teachers. People should be given the opportunity to communicate effectively in a variety of settings, for example, while doing activities in pairs, groups, while giving explanation to the whole class. Okay, now we will proceed to integrating communication into mathematics teaching and learning activities. We have 10 processes, which is the first one is promoting discussion, the second one is using visual aids, then the third one is utilizing technology, group work and collaborations. Next, effective questioning. Then the writings in mathematics. Next is feedback and reflections. Then real-world applications, teacher modeling, and the last one is creating a supportive environment. Now, let me describe every part of it. For promoting discussion, we encourage classroom discussion where students explain their thought processes when solving problems. This will help students articulate their reasoning and understand different problem-solving strategies. For the second one is incorporates visual representations such as diagram, graph, and chart to help students visualize mathematical concepts. This supports students who may struggle with abstract ideas and fosters deeper understanding. For the third one is utilizing technology. It will be integrated technology tools such as interactive whiteboard, graphing calculators, and educational apps to facilitate communications and explorations of mathematical concepts. This tool can engage students and make abstract concepts more accessible. For number 4, group work and collaborations. It will be assigned collaborative tasks that require students to work together to solve problems. This promotes peer-to-peer communications, which is encourage teamwork and allows students to learn from each other's perspective. Then for the fifth one is effective questioning. Use inquiry questions to stimulate discussion and critical thinking. This will encourage students to explain their reasoning, justify their answer, and ask questions to deepen their understanding. Next, we will go to the writing in mathematics. It will be incorporate writing activities such as journaling, reflections, and explanations of mathematical concepts. Writing will help students organize their thought, clarify their understanding, and communicate their idea effectively. Next, we will go to the feedback and reflections. It will provide constructive feedback on students' communication skill and mathematical reasoning. It will encourage students to reflect on their communication strategies and identify areas for improvement. Next, we will go to the real-world applications. It will connect mathematical concepts to real-world situations to demonstrate the relevance of mathematics in everyday life. It will encourage students to communicate how mathematical concepts are applied outside the classroom. Next is teacher modeling. Model effective communication strategies by thinking aloud while solving problems, demonstrating how to communicate mathematical ideas clearly and precisely. And for the last one is creating a supportive environment. It will foster a classroom culture where students feel comfortable expressing their ideas, asking questions, and making mistakes. It will encourage a growth mindset where students view challenges as opportunities for learning and improvement. Here's an example of how you might integrate communication into a mathematics class using teaching and learning activities. Here we will use activity PAK21, which is Think, Pair, Share. It will include introduction and setting the stage, individual solving, pair discussion, whole class sharing, class discussion and reflection, and the last one is closure and wrap up. Now we will go to Think, Pair, Share. Think is students are given a question or topic to think about individually. They take a moment to reflect and come up with their own ideas and responses. For pairs, students are paired up with a partner. They discuss their thought and idea with each other, sharing their perspective and insight. For share, pairs share their discussions with the whole class. Each pair has the opportunity to contribute, and the teacher facilitates the sharing processes. For Think, Pair, Share, we can use to introduce new concepts and promote problem-solving skills. Think, Pair, Share is an effective strategy for enhancing mathematics teachings and learning by encouraging active participations and fostering mathematical communications and understanding. Here's an example equation and its solution that relate to each step of the Think, Pair, Share activity in the context of solving multi-step algebraic equation. For example, 3x minus 4 equal to 14. In this part, teacher will introduce the topic of solving multi-step algebraic equations and explain the objective of the activity. For example, the teachers introduce the equation 3x minus 7 equal to 14 and explain the objective is to solve for the variable x. In part individual solving, students are given time to work individually on solving the equation. They apply their knowledge and algebraic manipulations to isolate the variable x. During this phase, students may use strategies such as combining like terms, isolating variables on the sides of equations, and performing inverse operations to solve for x. For example, students work individually on solving the equation. They will begin by isolating the variable x on one side of the equation, then adding 7 to both sides of the equation. Then they will get 3x equal to 21. Then they will need to divide both sides by 3 to isolate x, resulting in x is equal to 7. Next, in pairs discussion. After a designated period of individual solving, 5 until 10 minutes, students are paired up with a classmate. In pairs, students discuss their approaches to solving the equation, sharing their strategies, and comparing their answers. Students may explain their thought processes, ask clarifying questions, and offer assistance to their partner if they encounter difficulties. For example, they share their strategies such as identifying the constant and coefficient terms and explain how to apply the inverse operation to isolated x. Next, for whole class sharing. After the pair discussion, the teachers facilitated a whole class sharing session. Pairs are invited to share their strategies for solving the equation with the rest of the class. Students may use various methods such as algebraic manipulations, graphical representations, or verbal reasonings to explain their approaches. The teachers encourage active participants from all students, prompting them to ask questions. For example, pair shares their strategy with the whole class. One pair explained how they added 7 to both sides first, while another pair demonstrated how they divide both sides by 3 immediately after. In class discussion and reflection, after hearing from several pairs, the teachers lead a class discussion to summarize key strategies and insights shared by students. The teachers highlight different problem-solving approach. They emphasizing the importance of understanding underlying concept and also selecting appropriate methods. Students are encouraged to reflect on the variety of strategies discussed just now. In closure and wrap-up and reflection, the teacher summarized the main points covered during the activity and reinforced key concepts related to solving multi-step algebraic equation. The session concluded with a brief reflection on the value of collaborative problem-solving and mathematical communications in the learning process. Next, we will be continued with example 2. Here's an example of how you might integrate communication into a mathematics class using teaching and learning activities in using visual aids. For example, we are using graphing linear equations. In this example, we have visual representation, analysis and discussion, classroom discussion, and the last one is further exploration with this extension. Next, we will go to visual representation. The teacher introduced the equation y equal to 2x plus 3 to the class. For example, using a whiteboard or interactive display, the teacher graphed these equations on the coordinate plane, marking key points such as the y-intercept equal to 0, 3 and using the slope to identify additional points. Next, we will go into analysis and discussion. Students examine the graph and identify its key features, which is slopes and y-intercept. For example, they observe that the slope of 2 indicates that for every unit's increase in x, the corresponding y value increases by 2, while the y-intercept at 0, 3 represents the initial value of y when x is 0. Okay, now we will go into the classroom discussion. The teachers prompt students to consider how changes in the equation would affect the graph. For example, the teacher asks, what will happen to the graph if we change the slope to negative 2? Students discuss that a negative slope would result in downward sloping line, where for every unit decrease in x, the corresponding y value decreased by 2. Similarly, the teachers might ask about changing the y-intercept and adding or subtracting constant within the equation, encouraging students to predict the graphical outcome. Last but not least, we will go to further exploration or extension. Students explore real-world scenarios represented by linear equation and graph their solution, which relating mathematical concept to practical applications. Students are given equation in different form, for example, slope-intercept form, and they are asked to graph them independently or in pairs. For example, they analyze the effects of changes in slope, y-intercept, and coefficients on the graph. In conclusion, integrating mathematical processes into teaching and learning activities lead to enhanced understanding, improved mastery of a skill, developments of critical thinking and communication skill, promotions of collaborations and teamwork, fostering a growth mindset and preparations for real-world applications. This outcome contributes to a comprehensive and practical mathematics education that prepares students for success in school, career, and life. That's all from me. Thank you.